What's up everyone? In this video we're going to deploy VPC with VXLAN so that we can have redundancy for VTEPs. To better explain the benefits of VPC, I got this document from Cisco and it's very well documented. So I'm going to share this in the video description so that you guys can have a look at it. So let's say that we're deploying 3 switches, right? And we have a triangle. So on a traditional normal scenario, we would have one of the ports being blocked and only one of the ports being forwarding from switch 3 perspective, right? And if we try to create a port channel to combine these two ports that connect to both switches, this won't work because they are different switches. So with VPC, this configuration is possible as it will make switch 1 and switch 2 to appear logically as a single switch. So from switch 3 perspective, it's going to see that it's connected to a single switch. And there are some basic concepts that we have to understand related to VPC. And they are VPC domain, VPC keep alive, VPC peer link, and VPC member port and VPC orphan port. So in short, a VPC domain is a domain that is made of a pair of switches. It's like in MST region, so we have a name and those switches are part of that group. The peer keep alive, this is a layer 3 link. It is used to monitor the status of the peer. So it's going to send like UDP packets just to monitor whether the other peer is reachable. And we have peer link, and this is used to exchange information like MAC address and VLANs and this kind of stuff between the peers. And when we have one device connected to just one of the peers, that port is called an orphan port. And when we have a device connected to both peers, that port is considered to be a VPC member port. So this is just some fundamental concepts about VPC. We're not going to go deeper into VPC, but just to have an overview about VPC. Okay, so now in our topology, I did some changes, and that's what we're going to have now. So we'll have leaf 1 and leaf 2 members of VPC domain, and we'll use interface 1.3 as the VPC peer keep alive, and interfaces 5 and 6 as VPC peer link, and the ports 1, 4, they will be considered to be VPC member ports. Now, from a configuration point of view, we're going to continue from the VXLAN VPN symmetric IRB configuration. So this is already deployed, which means that at this level, leaf 3 is providing inter-VNI communication for 8 and 9, and leaf 1 and leaf 2, they also have the configuration in place. And what we're going to add is the configuration to allow the switch to be part of VPC domain. The leaves are already configured to allow layer 3 VNI or inter-VNI communication, and we can check that on R8, and R8 should be able to ping R9. So R9 should be on 20, yes, 29. And yes, I want to close this, but 5 and 7 right now they can't talk to each other. So if I try to ping 10 25, yes, and 27. Well, this is not working now because the traffic has to be sent to the leaves, and then they're going to be routed to R7, and that's what we're going to do now. Let me close this. So let's begin by configuring leaf 1. Okay, let's see what I have already configured. So VLAN 10, it is already, and VLAN 20 and VLAN 30. Not yet. And let me check. VLAN 10 and 20, 30. Okay. I have 10, 20, and 30. It's missing on leaf 1. Pass this here. And let's confirm that it has all the VLANs 10, 20, and 30. Awesome. So VLAN brief. Okay, and let's start confirming whether or OSPF it's okay. So underlay it's okay. Let's check BGP, auto VPN summary. It is receiving and probably advertising as well. So just make sure that this part is clear before diving into VPC. So EVPN summary working, great. Okay, so layer 3 VNI, it's deployed. So run BGP. We have layer 3 VNI, awesome. And just confirm that NV interface, okay. Okay, that's great. Okay, so we can begin by enabling the features. So we'll need VPC feature and LACP. Now the ports that we're going to use will be 1.3, 1.5, and 1.6. So let's confirm what I have in 1.3. Right now it's clear. Okay, and just going to place this inside VRF and 1.3 and say VRF member vPC. So I have to make this a layer 3 interface first. VRF member vPC. And the interface IP will be 192.168.12.11.24. Chat, sure. 1.3. Okay, awesome. And I'm going to do the same on leaf 2. And VPC via feature first. VPC. And feature LACP. Now 1.3 interface, see what we have now. So it's going to make a layer 3 interface and VRF member of VPC. And I didn't create, so first VRF context VPC and VRF member VPC and IP 192.168.12.12.24. And let's take a shot and see if we can reach leaf 1. So using VRF VPC. Okay, it's working. That's awesome. But now let's begin VPC configuration. VPC domain, let's say 1.2, and here keep alive. Okay, keep alive. Destination 192.168.12. Source from 192.168.12.11 using VRF VPC. Okay, and we're going to do the same here. VPC domain 1.2. This CPU switch, okay. And here keep alive destination 192.168.12.11, source from 192.168.12.12 using VRF VPC. So if we check show VPC, you can see that VPC keep alive status is alive. That's awesome. And now we want to create the peer link. So we're going to select 5, 6, and first make this a trunk port and channel group to mod active, and let's enable that 1, 2, and we're going to set as VPC peer link. Okay, we're going to do the same on leaf 2. So interface is 5 to 6. We bring the interface up each port, make sure mod trunk, and it's syncing. Okay, and let's create the port channel 1, 2 mod active. Now we go into port channel modes and we set VPC peer link. So now will begin the election negotiation process with the other peer. We look show VPC. Peer link is down, peer is alive, so probably still negotiating. Port channel is up. Let me enable logging on this as well. Okay, so let's see if where the port channel is up. So it's bundled, that's okay. Show VPC. Adjacency informed okay. Peer is alive, but configuration consistency status failed. And the reason is IP address does not match. So this is the improvement that we have to do related to VXLAN. As we can see, the loopback interface, the VTEP interface, this is the one that will be set as the next hop for the prefixes or MAC address advertisement to other peers. Now, to fix this problem, we have to make the fabric sees both leaf 1 and leaf 2 as a single device. And that's what our VPC is complaining about. Okay, so what we have to do is to add a secondary IP that is going to be referenced as the Anycast VTEP. And let me see if I get this in the document. Can I get it? Anycast. So yes, so that's what we're going to deploy is Anycast VTEP that will allow both leaf to be seen as a single device whenever they're performing, whenever they advertise the prefixes on the fabric. Okay, so we can see that based on this example, VTEP 1 or leaf 1 has one IP and leaf 2 has a different IP, and they will be sharing this Anycast VTEP IP, and that's what we're going to do now. So to get into the loopback, and we're going to create assign a new IP 100.42, and we'll say this is a secondary IP, and we have to do the same thing on leaf 2. So IP 192.168.0.132, that's going to be secondary IP. And oh yes, another thing is that recommended to shut down the interface before making this change, and then bring up. Okay, now it's better. Now if let's check VPC status. So right now I should be negotiating, because they still can't see each other. That's okay. So now it's just a matter of NVE interface change its status. So NVE, it's up, that's okay. So VPC adjacency informed, peer is alive, so this is the secondary. Okay, that's awesome. Let's check again here. It's formed, peer is alive, and everything. It's okay, it's aligned. That's awesome. Now let's configure the VPC member port that connects to the switch. And so we're going to interface 4, 4. Okay, so make sure it's a layer 2 port and it is a trunking port. And we're going to create channel group 4. Okay, and get into port channel 4, and we'll say VPC 4. Okay, and we're going to do the same on leaf 2. So 1, 4, just make sure that it is ready. Okay, so it's already configured. Mod track, let's double check. And okay, channel group 4 mod active. For channel 4 VPC. So it's going to get the ID from the port channel number. I don't have to type in. And now let's bring the switch, and we have to configure port channel LACP. So let me disable some basic stuff. And privilege level 15 host names. Okay, PC. Okay. So it's interface E1 and 2. 0 E01, E02. Oh, not a Nexus. And 1 and 2. Switch port trunk encapsulation, and then mod trunk. So channel group mod active. Now it will begin to negotiate LACP trunking, LACP port channel with leaf 1 and leaf 2. Meanwhile, let me create VLAN 10 and 20. And VLANs, these VLANs will be assigned to E00, switch port host, switch port access VLAN going to be 10, and 03, switch port host, switch port access VLAN 20. Okay, that's great. Now let's see if our channel is up. Okay, that should be it. Channel summary. It's bundled, it's up. That's awesome. Do we have something already? Do show MAC address. Okay, and you can see that we have R7 MAC address and R5, and these are the leaves MAC address. Okay, so let's just confirm from the leaves perspective, and it's up. Okay, that's awesome. That's what we want to see. Confirm on the other leaf as well. Show VPC, and it's up. It's working. Okay, so now let's see if we have reachability. So can R5 reach 27? Yeah, we can. So we have inter VNI reachability just at this level. So now let's see, can R5 reach 10.8? Awesome. So which means that traffic is leaving these leaves and is able to reach leaf 3, and it should be able to reach 29 as well, and it does. Okay, so that's it, guys. VPC with VXLAN deployment. I hope you guys enjoyed, and I'll see you in the next one.